Just before we get started, I just want to begin by acknowledging the traditional owners of the land on which we meet today, and I would also like to pay my respects to elders past and present. Thank you, Paul, for that really excellent introduction. I didn't realize this stage has a whole crowd warm-up routine, which is fantastic. We need that when we're getting to this time of the day, because I know there's a lot of sessions, a lot of content, and we've all been going since really early this morning. So I'm here today with Jad Goss and Rob Lowe from RACQ, who I'm going to invite up onto the stage in a minute. But I just wanted to set the scene just before we begin on the topic today. So using generative AI securely, safely, and responsibly. So when we look at using AI, we have to ask ourselves, what is responsible AI to begin with? And at AWS, we have defined these 6 pillars which we try to use when we're looking at the use of responsible AI. That includes things like fairness. So is the model output treating different populations fairly? You know, equal balances of gender, ethnicity, those sort of things. Sometimes we tend to get responses from models, and as humans, we're pretty good at judging these things, but models don't really pay attention to these things. So it's just something that we need to keep at top of mind. Explainability. So do we know how our model arrived at the outputs that it's giving? So do we know what factors went into the content that's coming out of the models? There's robustness. I mean, anytime we're building applications, resiliency is a huge focus. We need to make sure that our systems are operating reliably. Privacy and security, obviously another very important thing. Security is top priority at AWS. With generative AI, it's no different. Model governance, so processes to define and implement and enforce responsible AI practices. So thinking about how you can enforce your generative AI policies that no doubt many of you are starting to see come out from your organizations. And then finally, transparency. So communicating information about AI systems as stakeholders can make informed choices about their use of the system. So things like AI model cards, informing your end customers how you're using generative AI in your services. But without further ado, I'd like to invite up onto stage Jad Goss to take us through RACQ's journey with generative AI.
Cool.
Thank you, Jad.
Thank you, Simon. Hello, I'm Jad, I'm from RACQ. So, RACQ has been helping Queenslanders for over 118 years. We're owned by 1.7 million members, and we offer roadside assistance, motoring services, insurance, banking, travel, and solar products. So, my colleague Rob and I, we've been using generative AI since early last year. It's only been in the last 6 months that we've been using it fairly intensely. So we're currently working on an app backed by generative AI. It's for use internally, and it's for a scenario that some of you may be familiar with. So if you put an insurance claim in for your car or your home, and a few weeks later you want to call and see how it's going, when the agent takes the call, that agent needs to get up to speed with everything about that claim really quickly in order to give you the best service. And so if it's a simple claim, that's not a problem. We have things in place that make that an easy job for our agent. But if there's a lot of information, if it's been going on for a while, there's lots of builders reports, if there's been flood damage or something like that, it can take a long time for the agent to get up to speed by reading emails and builders reports and that sort of thing. So our solution is going to help them get up to speed really fast by getting Gen AI to interrogate that information. We're using 2 prompting techniques called topic detection and key point summarization. I'll explain a bit more about what they are in a moment. And Rob's going to give us a demo of how this thing works in the back end, which I think you'll all appreciate. So when we started all of this, we knew we wanted to achieve 2 things simultaneously. We wanted to jump in early and work towards an MVP, but we also wanted to establish a practice of using AI responsibly. Why do we want to jump in early? Well, I think we can all see the opportunity that Gen AI is bringing. So when I was trying to put this slide together, I was trying to think about how can I describe this in simple terms, and I came up with these 3. And the first one I think we've all experienced, its ability to understand natural language and its ability to respond with natural language. The second one, I didn't come up with this term, I was trying to think of a way to describe Gen AI's ability, or large language model's ability, to do things like pass the bar exam. Like, what is that? What's that superpower? and of course I asked ChatGPT to help me with the term, and it came up with this, advanced cognitive emulation, which I think is awesome, mainly because it didn't say advanced cognitive abilities, which would have been comparing itself to a human, which would have been a bit unnerving. But if you combine that with the ability for language models to follow instructions, those two things really combine to make, you can do anything really with the generative AI. But you've got to get your instructions right, you've got to get your prompting right. The other reason we wanted to jump in early was a competitive advantage. Just want to get ahead of the game with all the other insurers. Also the change management. If we start this process early, then the change management for the organisation is going to be a lot easier. Same with the learning curve, with any training that staff may need to undergo with generative AI. So that's why we jumped in early. The reason we wanted to establish a practice of using it responsibly was because at the time we started looking at Gen AI, Rob and I were helping out with a data governance project. And so security, PII, sensitive information about customers, this is all front of mind, and we saw that the problems with data governance is when you start the process too late. So we didn't want to make that mistake with starting with Gen AI and leaving all of that responsible approach to the end. We wanted to do it straight away. So we started looking around for information on how to do it responsibly, and as it turns out, there's quite a lot. A lot of governments are now coming out with guidance for corporate industry to do it responsibly. Tech companies like AWS are providing great information. We're going to hear more from Simon about what AWS can do to help people like us use their tooling responsibly. And as for tooling, we're really not short of anything. We have everything we need. We haven't really found a tool that's not available in the AWS stack. When you combine those two things together, we thought we would have some idea of what to start first. But as it turned out, the surface area that we needed to consider with responsible AI was so broad that we needed to come up with another way to narrow down what we were going to start with. So we decided to do some proof of concept applications, and we started with the one that I think we've all done: take a document, feed it to an agent, a large language model, and ask it questions. But obviously, the context window is an issue. You can only fit so much in one prompt. And as it turns out, the old adage of garbage in, garbage out with data quality is still a thing. You've got to make sure you've got your data sources right. So then we started to look at RAG, Retrieval Augmented Generation, and we think we're going to be doing this in the future. It's a great technique, but you've got to get your data right, and you've got to get all the configuration of the chunking and the vector database right, and we're going to do that, but it was just a bit too much for us to bite off as a first project. We looked into topic detection. Another word for this is entity extraction. It's where you ask the model to pull out certain things from the text, such as categories, topics, entities, and this is really good, but if you're going to make use of this, we found that we really needed to get our completion structure correct. And when I say that, I mean telling the model how you want it to respond. What format do you want that response in? Obviously, we played around with summarization. I think that's an amazing ability for generative AI in business, but we quickly found that if you ask an open-ended question to a language model, you're going to get an answer that's quite hard to evaluate. But in the end, we chose topic detection and a version of summarization called key point summarization as the two techniques that we were going to leverage. So we had that ready to go. We knew what techniques we wanted. Now we needed to decide what application to build. And we decided that we didn't want to use what would have been ideal, which was a language model backed with all the claims-based information that it needed, and a staff member communicating in a chat-based scenario. That would be ideal, but it was just going to be too hard for us to evaluate the responses that were coming back from the model. We couldn't anticipate the questions, couldn't anticipate the responses, so we just decided that's too hard. So we instead crafted what we know the agent is likely to ask of this data, and we put those in prompts, and we passed that along with our prompt in certain chunks to the language model, and we took that response and put that in a database as a new data source, as new insights. And then we put the application on top of that and provide that to staff. We also made sure we crafted our prompts very specifically, no open-ended questions. Again, too hard to evaluate. We decided to version control our prompts, and we also went through a very iterative cycle of testing. So we now had our technique for prompting. We knew what application we wanted to build, but RACQ was still coming up with its responsible AI guidelines. We didn't want that to hold us back. We wanted to do something. So Rob and I put some guardrails around ourselves, how we were going to approach this project. We decided to work entirely within our AWS environment, which meant we didn't have to consider anything traveling outside of our network. We built an auto redaction service early on so that any data we were using was stripped of any PII and sensitive information. We used the best models available because the models are only getting better, and we knew by the time we get to production, there's going to be a much better model. So we just used the best ones that were there, and the cost wasn't really an issue because we were only in dev mode. We're making sure we record data lineage, I'll speak about that in a minute. We did showcases with the team to make sure that everybody knew, they knew there was a generative AI project going on in-house. We didn't want them to have any concerns about how it was being handled, so we made sure we presented to everybody. And the last thing is the most important, I think, and this is what we're doing right now. This is how we're going to evaluate the responses that we're getting back from the model before we go to production. And so there's actually quite a bit of information about this online, but there's no real standard on how to do it. So we've chosen these 3 metrics that we're going to use. We're going to use some traditional machine learning techniques to get metrics for each of these, and we're going to choose a threshold for each, below which we're not going to send this thing out into production. So you might be asking, well, what can you do to improve these metrics? Well, there's actually quite a lot. I mean, prompt engineering is an entire discipline. So we've carefully crafted our system prompt and our user prompt. Importantly, we're putting in a completion schema. I mentioned that at the start. This is where you get a JSON schema, an actual schema, and you provide that in your user prompt, and at the end of it, you tell the model that you're only to respond in this format. The reference documentation is important because insurance is a highly regulated industry, and even though there's going to be a lot of information in the training data of the model that you're using about insurance, we don't want it to use that. We want it to make any acronyms or terms that it comes across, we want it to use the ones that we have, that we use in-house. And we've actually told it, if it comes across any other terms outside of what we have in our reference documentation, just ignore it and tell us that you've encountered this term, and then we can use that to then update our reference documentation. Obviously we're passing business data in, we're passing in notes about the claim, we're passing in transcripts, we're passing emails, and then there's the model selection and parameters. We can tweak those as well to change the responses that we're getting. Version control, I'd highly recommend you version control everything. The prompt, the completion schema, the reference data, because at some point you're going to need to link up what you're sending to the model with what you're getting back to it. And that's the data lineage I mentioned. We're very mindful of that from the data governance projects that we've been doing. And also, we're logging everything. We're probably going to have a very large S3 bucket, but at this stage, we're just logging everything we send to and from the model. Finally, we're going to involve our end users. So when we put this, we're building a Streamlit app, that's the front end. We're not going to bother showing you that because that's not the exciting stuff. It's the back end stuff that's exciting. But when we do present that to users, we're going to make sure we clearly label all the generative AI content so they know what they're seeing. We're going to show the prompt behind that Gen AI content. We're going to show what data wasn't used in order to generate that information. So it's good that we've included the information we have, but there's some that we don't have available yet. So we want to make sure that they know that they might need to go and supplement that answer they're getting from generative AI with their own research. And we're also going to gather in-app feedback. Those metrics I was telling you about earlier, we're going to gather those from staff as well. All right, that's how we came about deciding on our app. I'm now going to hand over to Rob, and he's going to take us through how it looks in the back end.
Thank you, Jad. I'm Rob Lowe from RACQ. So as Jad mentioned, we developed a claims research assistant application with the primary objective to reduce the time it takes for our employees to get familiar with and up to speed with a claim and its associated complaints. We're bringing together multiple natural language data sources from multiple systems, such as notes from our claims management system, call transcripts, and identifying key entities within these data sources in order to analyze a claim and its associated complaints. We wanted to build our solution using event-driven architecture to provide our employees with the ability to select a claim to be processed in the shortest amount of time possible. Unfortunately, we're not at this point where we've got a single view of a claim solution as yet. We're still missing some data sources, such as emails and documents that we're busy working through. From an app flow perspective, an employee has the ability to select a claim within a UI. This would trigger off a workflow. The first part of the workflow is to go gather the data from our data lake, redact it, and save it in a predefined format. So you can imagine a data set containing a list of notes, some of which are user notes, others are system notes from a claims management system. We'll pass this data set to a large language model with the instruction to go and derive topics for each of these individual notes. Topics could be seen as a category or grouping, such as member dissatisfaction or financial hardship. We'll take that same data set and pass it again to a large language model, now with instruction to take these notes and generate key points. And finally, we'll take these key points and summarize them. From an architecture perspective, we're running a Streamlit app on an ECS cluster. We're authenticating our users using an Azure Enterprise app. Within the Streamlit application, users have the ability to go and view claims that have already been analyzed, or they can select a claim to be analyzed or even reanalyzed. In that particular scenario, it will kick off an API call to API gateway, which in turn will execute a step function. And we'll talk to the step function in a lot more detail in the following slide, but in essence it performs two main tasks. The first task is to run a glue job, querying a FINA, and then using comprehend to redact that data. It stores the output of that redacted data in S3. And we're also updating several DynamoDB tables which our app can then later use throughout the process. The second task is to use that redacted data with a Lambda function and an LLM to analyze it. And we're currently in the process of evaluating several of the SageMaker language models. But now that Bedrock's available in Sydney, we really want to explore what Bedrock has to offer. This is a demonstration of a claim that's already been processed. At this point in time, a user has selected the claim number itself. We've recorded the claim number and the user's details and store it in a DynamoDB record to start with. Although this is a pre-recorded demonstration, the step function itself takes about 15 minutes to complete. So I'll just walk through the steps, what it actually does. The first step is to go and run a glue job. And during the glue job, it will go and pass certain credentials to the glue job, such as the claim number that the user selected. It will pass event run UID. The event run UID can be seen as a UID we generate for the particular batch. It will also include a step function execution ID for this particular batch run. At this point in time, the glue job will go run a set of queries against the FINA for this particular claim. We'll go redact it, store it for us in a format we can use in S3 in subsequent steps. If anything were to go wrong during this glue job process, we'll fail the step function and we'll notify the particular user that this claim has failed for whatever reason. In this case, it was successful, and we'll move over to the next step, which is generate prompts. During this step, we'll call our orchestration function for the first time, instructing our orchestration function to use that data set and to go break it up into smaller manageable data, or batches rather, which we refer to as prompt chunks. The prompt chunks themselves, we're using Python libraries to go and derive them, and we're storing them in DynamoDB as item records. Within DynamoDB, you'll see a prompt chunk example here, including the event run UID, the timestamp, the type of prompt, like topic mentioned, the event type, such as note. We're also including a system and a user message. The user message itself will contain a subset of the data that we associate to this particular prompt chunk. And we'll also have an initial status of queued. Once we've derived all our different prompt chunks, we'll go and process them using a map function within a step function. And in this map function, we'll pass an array of items which we'll use to work through. In this example, we're generating a payload, including the iteration number. We're changing our mode from generate prompt chunks to run prompt chunks. We're including the claim number. We're passing a prompt of topic mentions. We're including event type, as well as event run UID. And these values will then be passed on to our Lambda orchestration function as an input payload. Lambda will then use these values to query DynamoDB and derive all the prompt chunks that relate to these particular values. It will then go work through these individual prompt chunks one by one. As it completes a prompt chunk, the status will change from queued to completed. If a particular prompt chunk were to fail, we'll increment our error counter and try that particular prompt chunk at least one more time. We'll repeat that process several times up until all the prompt chunks for this particular iteration has been completed. Once this iteration is done, we'll move to the second iteration. And similar to the first iteration, we'll generate a payload which we can pass to a Lambda orchestration function. But in this case, we're changing the prompt from topic mentions to key points. And again, we'll then process all these different prompt chunks, save the completion responses. If it fails, we'll notify the user. In this case, it was successful, and we'll notify the user that this particular claim can now be viewed within the UI. We've gone through a few prompt engineering iterations. These are some of our more recent prompts, or system message and user message rather. The system message would contain an instruction that we're using to try and provide the large language model with some context how to analyze data that's relevant to us. We're also injecting additional information, such as a glossary of terms with terminology that's relevant to the insurance industry. Within the user message, we're injecting several parameters, such as the business system type, event type. We're also including a list of topics to assist the model in deriving those topics or categories, if you like. But probably more importantly, we expect the large language model to provide us response in a predefined JSON document format, because we need that format in order to store it and surface it back within the UI. This is an example of one of our completion schemas for topics. In this particular completion schema, we expect the large language model to provide us with one or more topics. We expect the large language model to provide us with a quote or extract of the data it used to derive these topics. And we also expect the model to provide us with any keywords or phrases it was uncertain about, which we can then use to refine our prompt to improve the accuracy. In summary, we're starting to unlock value using generative AI. We've identified a few low-risk internal initiatives to focus on. We're becoming more proficient in our prompt engineering techniques. We're also becoming a little bit more proficient in a way in which we process large amounts of data using LLMs. And we've identified a few new ways of implementing and practicing responsible AI within RACQ. At this point in time, I'd like to welcome back Simon Cousins from AWS.
Thank you. Thanks, Chad and Robert. Really great story. All right, so I just want to use the last few minutes to go through how to build responsibly and securely in AWS more generally. So our commitment to develop generative AI is in a responsible way is integral to how we approach this at AWS. So we're committed to taking theory to practice, maintaining end-to-end responsibility throughout the generative AI lifecycle. We're committed to educating you, our end customers, on how to use generative AI appropriately and securely. And we also want to advance the science behind generative AI and building generative AI responsibly. With our North Star, as you heard in the keynote this morning, to really be able to help you and build, and for your customers, build generative AI that's safe, trustworthy, and helpful. Now, at all times, AWS helps keep your data private and secure. So no customer data is used to train models. Your data is encrypted, and your fine-tuned models are all encrypted in Amazon Bedrock with custom managed keys or AWS managed keys. And I'm going to talk about more of that detail on the next few slides. So again, you're always in control of your data on AWS. That means customer data is not used to improve the Amazon Titan first-party models. And also any fine-tuning or any data you share with any of the models in Amazon Bedrock, all those models are deployed into separate tenancies, and neither AWS nor the model providers have any access to customer content, as you would expect with AWS. Customer data, prompts, and responses are all isolated, and of course, your data remains in the region in which you're using it, and thankfully, Bedrock is now available in the Sydney region, so nobody's got any excuses now. You can all go and build straight after this and jump into the console with Bedrock in Sydney. Next. So all the usual stuff applies with Amazon Bedrock. So TLS encryption, at least 1.2. We're slowly moving everything across to 1.3, or quickly, I should say. It's all fully integrated with AWS Identity and Access Management. So you've got complete control over who's got access to what and under what conditions, with fine-grained permissions. And of course, you can use AWS CloudTrail to track API usage and who's doing what in the cloud. And then finally, you've got fine-tuned models that are encrypted and stored using, like I mentioned before, with custom managed keys, which can encrypt your fine-tuned models and encrypt all of your data safely. Now, when we talk about Amazon Bedrock, we've got the concept of single-tenanted and multi-tenanted endpoints. So with a single-tenanted endpoint, you've got a deployment that's available to a single customer. That works like a single version of a baseline model, but it's been fine-tuned by a customer. So we create a copy of it, it's got your model weights in it, and that's only available to your applications. Now, the multi-tenanted endpoints are just the base models that haven't been fine-tuned, so they're available to all customers. However, every request is separated from each customer. It holds a baseline version of each supported first-party or third-party model, and they're all replicated in each region. So there's no inference requests or input text that's used to train any models in the deployment. Model deployments are inside your AWS account and are owned by an operator. Say that again. Models are deployed in the Amazon Bedrock account, but you make secure requests through your AWS infrastructure from your VPC. Now, really quickly, because I've only got 2 minutes left, here's a quick architecture diagram of how Bedrock actually works. So over on the left, I've got the other hand, client VPC. On the right-hand side, I've got the Amazon Bedrock service account and corporate network down the bottom. So of course, everyone's familiar with this access pattern. You can go through a NAT gateway to access the public endpoint for the Bedrock service. Do want to remind everyone here, though, that even when we do talk about public endpoints, all of your data remains, all of the traffic remains on the AWS backbone network. Nothing leaves the region. It just uses public IP address space. And of course, your clients can access, from your corporate network, can access the Bedrock public access endpoints through the internet. But for extra layer of security, you can use VPC endpoints through private link. And of course, you can backhaul your corporate traffic through Direct Connect or site-to-site VPN if you want to keep all of that traffic private. AWS Identity Access Management applies as per usual. So you've got full control over who's got access to what. And this is an example policy that you can use with Amazon Bedrock. So you can actually specify policies that mean you can control which roles and groups have access to which models and what actions they can take. Now, there's a QR code up here on the screen where we've got a responsible AI hub that's got a whole host of resources that you can refer to after this. And it goes through a lot of the stuff that Jad and Rob talked about. But yeah, feel free to take a snap of that. But you can also search that online and you'll find it relatively easily. So just to really quickly wrap up, concentrate on these 6 best practices for success. So define your use cases, prioritize education and diversity, assess your risk, test, go through iteration and adjustment, and make sure you're thinking about governance, guardrails, and monitoring, just as you would do with anything else on AWS. Don't forget you've got a free trial of Skill Builder, so there's 7 days free access just by going to skillbuilder.aws. I use it all the time. We always use it at AWS to get up to speed with new services. Pretty hard to keep up with 200 services, but that's a great resource. And finally, I'd like to say thank you for coming along. Thanks for listening to Jad and Robert. Do you want to come up on stage? Thank you very much for sharing your story. Really appreciate it. And don't forget, if you like this session, 5 stars in the app. Thank you for coming and enjoy the rest of Summit.
Thank you.
Thanks.